ability to impersonate that user across multiple websites. Maybe it could be their banking system, which is kind of the worst place to get attacked, right? Or disgruntled employees who have access to the database can misuse this. If they can see the user's passwords in plain text, they can misuse it in a number of ways. And it violates GDPR. There's a bunch of other laws around this, but GDPR, just because it's the most relevant one for UK, it violates GDPR. GDPR specifically calls out that you cannot store passwords as plain text. Otherwise, you will face penalties. Now, it's an open-ended question. How can we solve this problem? There's so many different solutions to this, but like I said, we're kind of building our knowledge step by step. So let's start with the first one, which is, we're going to try to learn some important concepts in security, and then take that knowledge and come back to this question in a few minutes. So the first concept I want to talk about is hash functions. Hash functions are functions that provide a unidirectional transformation of an input into a fixed length string. There's a lot to this definition, so I'll try to break it down. Same input always produces the same output. That's property one of a hash function. It's also computationally infeasible to reverse a hash, billions of years using current technology. The computers that we use today, they're not fast enough to reverse a hash in the other direction. That's why we call them unidirectional. Not because it's impossible, it's just it will take you billions of years. There are things about quantum computers that could break certain hashes, but we're fine for now. And I think the best way I can kind of talk about hashes is by showing you guys what they look like. So let me see how clicking links work in here. There we go. So what I have here is, someone on the internet made a hash calculator. It shows you all the different algorithms that are out there to produce hashes. One of the most popular ones, I'm sure some of you have heard of this, is SHA-256. 256 stands for 256-bit. That's the length of the string that it produces, and SHA is, I think, named after the researcher. But the way hashes work is if I type in password 123, it produces a fixed length string as an output. And the best part about a hash function is if you take this string and I ask you, what does this mean? You probably cannot tell me. Even if you have super fast computers, you won't be able to reverse it in the opposite direction just because it will take you billions of years. There's some mathematical magic happening under the hood to make this happen. There are fundamental problems in mathematics that we cannot solve with the algorithms that we know now, which makes this possible. It's a lot of interesting stuff in there. But yeah, the gist is you have a string, let's say password, it produces a hash, and we know the string password will always produce the same hash. So let's go back to the presentation. Let me see how, there we go. So yeah, just to kind of recap what we saw they produce a unidirectional transformation of an input into a fixed length string. In our case, it was 256-bit. The same input always produces the same output, and it's infeasible to reverse a hash. There's another important concept called encryption. Again, some of you might have heard of this, but it's another way to transform data. However, the difference is it's bidirectional. So what that means is you take a plain text in our case would be, let's say, password 123. You encrypt it, and you get ciphertext out of it. But when we're encrypting it, we can go back to the plain text by using the encryption key that we've used to encrypt the plain text. There's usually two popular types of encryptions. There's symmetric encryption. Symmetric encryption uses the same key. That's why it's symmetric for both encryption and decryption. So, one of the common use cases is data encryption at rest. We talked previously about storing passwords in database and how disgruntled employees can get access to it and cause havoc. Data encryption at rest is one of the things we could use to encrypt the database with a key that only some people have access to. So no, not everyone can go and look at the database and just look at all the passwords of every user. Yeah, like I said here, encrypting your database is one of the use cases, or even encrypting the files on your laptop. I think Mac OS has a feature where you can encrypt your hard disk with your password. So if someone gets access to my laptop physically and they try to take out the hard disk, if it's not encrypted, they could, in theory, see all my files, all my data. But if I have the encryption enabled, they would need my private key, which in this case would be my password, to get access to all the files. There's another option called asymmetric encryption. It's asymmetric because there are two keys, a private and a public key, that are used for encryption and decryption. Public key, kind of from its name, is public. You can share it with the world, but private key is something that you keep private, hidden. You don't want to tell anyone about this. There are protocols and technologies that are built on top of this encryption. HTTPS, SSL, or like that lock that we see whenever we access any websites, that's what HTTPS is. And it uses a combination of both types of encryption, but asymmetric encryption makes it possible. And then we have sign in with Google, makes it very convenient to sign in with Google. You don't have to enter your passwords anywhere. That's also built on top of asymmetric encryption and JWT tokens. This is something I'll cover at the end, but I just want to call that out as one of the use cases. Yeah, and kind of the third and the last thing I want to talk about as important concepts, encoding. Again, they kind of start to sound similar, but I want to call out the distinction early on because they're going to come together at the end of the talk. So encoding, again, is a form of transformation of data from one form to another. But in this case, it's to make it easier to transmit and store. Mostly because different systems have different ways of talking to each other. So you encode the data into a different form to make it easier for that system to understand what you're sending. And it's easily reversible. There's no secrecy involved, nothing related to encryption or hashing. You can go from one form to another and back to it. Yeah, not meant for secrecy. And I think you might have heard some of these names, but base64, URL encode, or Morse code. Morse code is a form of encoding. And here I have another link to kind of see it in action. So you have a lot of different ways you can encode or decode things, but let's say in our case, we want to encode hello world. Here you'll see all the different types of encoding that we can use. I think the most common one you'll see is base64. So it converts hello world, which has a space in it. As you can imagine, some systems might not like the space for reasons. So we encode it in a different form, which gets rid of the space. And then we can kind of take this and pass it to a base64 decode, and we would get the original string back. Morse code as well. This is what it looks like in Morse code, if anyone's interested. But yeah, multiple different types of encoding are out there. They all have their own use cases, but I think base64 is the one that is most commonly used in a lot of different systems. Let me go back. So just want to summarize kind of the three different things we talked about because they tend to be confusing. But yeah, like encoding transforms data for compatibility. It's easily reversible. Encryption transforms data to keep it secret, requiring a secret key for reversal. Hashing, on the other hand, transforms data into a fixed length, irreversible representation. And let's go back to our original problem that we tried to solve. I kind of took a detour here just to talk about these concepts, but we'll see how they come into action to the problem we're trying to solve. So I kind of mentioned all of this earlier, like why storing passwords as plain text is bad, and we kind of stopped here before we took this detour. How can we solve this problem? We kind of saw hashing in use. We can hash them before we store them, right? In the database, they will look like this long length of string that no one can read, and if I give you that string, you won't be able to tell me what it is. so users' passwords are safe, right? To authenticate users, we can compare the hashes with each other. So when the user comes to our application, they enter their password, we can hash them and then compare that hash with the hash we've stored in the database. So you're no longer comparing plain text with plain text, you're comparing hashes with hashes. There is one problem though. In security, we tend to have problem solutions. It's kind of an ongoing battle between attackers and researchers. Rainbow tables. I love the name. Rainbow tables are a way to basically make hashing insecure. Rainbow tables essentially provide the attackers a table which contains the hash as the primary key or the index and the value of the password that hash comes from. What this means is, as an attacker, I can basically look at all the words in the dictionary or all the passwords that people commonly use, like password 123, compute their hashes on my laptop. And it would take me maybe a couple days, but then I can share it with my rest of the hacker friends, and it ends up being 1 terabyte, 2 terabyte files. But now essentially I have this table where I can do a reverse lookup. So when I get access to the database with hashed passwords, I can refer this and get the original password back. So we're back to the same problem, where hashing doesn't solve what we're trying to solve. Like I kind of mentioned, hackers can pre-compute the hashes of common passwords and store them in a table. If a hacker gets access to the database with hashed passwords, they can do a reverse lookup in the rainbow table for the plain text. How can we solve this problem? Salting. It's an actual term. Salting refers to adding a random string to each password before hashing. So what we're essentially doing is, without just computing hash of the plain text password, we're adding a salt to it. And salt is a random string that we generate on the fly. As the salt is random, different salts for the same plain text will lead to different hashes. What that means is, even if you have the same plain text, because the salts are different, the hashes end up being different. Which essentially means that the rainbow tables are impossible to compute for every possible salt for every possible password. All we did is, instead of hashing the passwords themselves, we prepended or added a string at the end, which is random and generated on the fly. And that leads to a completely new hash. So for example, for password 123, we added ABCD, sometimes DEF, even for the same password. So the hashes end up being different and the rainbow tables are useless. And I just want to call this out. A popular algorithm we can use in Node.js JavaScript land is bcrypt. They have implementations for different languages as well, but this is what I usually end up using. Let's move on to the next topic of this talk, authorization. What can you do? Supporting different roles is one of the things that authorization is used for. So we mentioned earlier, let's say you're building an app that has two different types of users, read and write, read only. This is a different question to ask than who are you? A user can be, let's say in my case, Mihir, but which role do I have is a different question. So we need some different technologies to kind of help us achieve this. Once we've authenticated the user, we've answered the question who they are by comparing their username with their hash password, we need a way to enforce the roles on the server. In other words, a user with read-only permission should not be able to write to the database. That would be really, really bad. Or in the case that we talked about, a student being able to view other students' grades. That would be, the university would probably face a big penalty if that were to happen. JSON Web Token, or JWT, is kind of the most popular way of authorization in JavaScript and a bunch of other languages. So I'll just kind of skip to this specific technology. There are multiple other ways to implement authorization, but this is the one that you'll most commonly see. So the user provides credentials to the server, like we saw earlier for authentication. The server verifies the credentials. If it's valid, the server creates something called a JWT that contains information about the user. For example, the roles, the expiration time of that token, other things. So I'm just going to have a sip of water. Yeah. So now the server sends the JWT back to the client, and the client stores that JWT. And for every request that the client makes to the server, it sends that JWT token back, usually in something called an authorization header. It's part of every HTTP request, and it just sends it back saying, this is who I am. This is the token you gave me when I authenticated myself, and now this is who I am, trying to read grades or trying to overwrite grades or whatever you want to do. The server looks at that JWT, and it verifies that it is what the client is saying it is, and the contents, which in our case would be the roles that we assign to the user, to authorize that request, and life goes on. Now, this is one of the technologies that will use all of the things we talked about previously. So JWTs use a combination of hashing, asymmetric encryption, it's the public key and private key encryption, and encoding all together to make this happen. It's really, really cool. A JWT token is broken down into 3 parts, usually something with a period, something with a period, and then something, so 3 different parts. The first part is called the header, which contains the information about the type of the algorithm used to create the JWT. So for example, you'll usually see RS-256, which refers to RSA. This is an asymmetric encryption algorithm alongside SHA-256, the hashing algorithm. So for the header, it's basically using a combination of asymmetric encryption and hashing to generate that header. We'll see what it looks like in a second, but just bear with me in the meantime. The second part is the payload. Payload is kind of what we really care about, which contains the roles of the users. So are you a read-only user? Are you a professor? Are you a student? Things like that. And the third part is the signature. Signature, it depends on how you look at it, but is one of the most important parts of the JWT. It is essentially generated by encoding the header and the payload. So again, encoding, which is in our case would be base64, using a hashing and an encryption algorithm. So it's literally using all 3 of these things together to create something called the signature. We'll see why signature is such an important thing in a second. I just kind of want to mention benefits. So if you use JWT, you can verify the authenticity and the integrity of the token using the signature. These 2 terms are there for a reason. Authenticity means that we know it's authentic, so the user is what they are saying they are. And integrity is someone didn't try to mess around with the token before it got to the server, so we know the token hasn't been tampered with. This is, I think, a very important thing in security where, let's say you're downloading Google Chrome from the internet. How do you know this is Google Chrome and not some malware that someone wrote that you're just going to install on your computer? JWTs are widely used for authorization in JavaScript applications, and JWTs are also used for single sign-on SSO flows like sign-in with Google. Whenever you're signing with Google, there's a really good reason it's using JWT in the background. Let's see them in action for the fun part, right? There's 2 links I'll go over, JWT generators and JWT visualizer. So first thing we're going to do is we're going to try to generate a JWT by using, let's use RS-256, which is the RSA with SHA-256 algorithm. We'll create a key. This is usually how the keys look like. There's a private key here and a public key on the right. And then what we'll do is we'll create a JWT with roles of, let's say, student. And once we create the token, this is what it looks like. It's complete gibberish, and it's base64 encoded, so you can send it over to multiple systems, they will all be fine with it. And once we look at the visualization, we'll see that we can go back and see what's contained inside that JWT. So I'm going to open up this link. I'm going to paste my token here. And you can kind of see from this gibberish, I essentially got back the role student back. So what we did, to summarize, is we generated a JWT using a public and private key that we generated on the fly. We didn't touch the header because this is already set to the keys that we're using above. But what we really care about is the roles, which in our case is student. And we can essentially send that to the server. And when the server decodes it, we get back the role. So now essentially you have a way for the client to tell the server that this is who I am and these are my permissions, so let me do whatever I need to do given my role. The important thing that I mentioned earlier was a signature. So how do we know, someone else didn't write this JWT which has this payload but was signed by a different key? You can actually check if the JWT is signed by the server by using the public key here. And then you can go back and then you can enter that. And then you'll see here signature verified. So unless you have that public key or private key, you cannot issue that JWT from the server. So as soon as I remove anything, it says invalid signature. So hope that made sense, but that's kind of the benefits of JWTs, and this is usually how we implement authorization in JavaScript or most other technologies. Just to summarize key takeaways, we talked about the best practices of storing passwords in the database to protect against rainbow table attacks by using salt-based hashing algorithms like bcrypt. We discussed the differences between encoding, hashing, and different types of encryption, asymmetric and symmetric. We talked about JWTs very briefly because it could be a whole talk of its own, their structure and their benefits. And that's really it. Thank you for your time. And I hope this was valuable.
Honestly, really great talk, really clear, really concise, very interesting as well. Do we have any questions for Mihir in the room? Yeah, down the back.
Thanks for talking. I have two questions about storing a couple of bits that you mentioned. Number one, salt is randomly generated for each time. So I'm storing a hashed password and I have generated salt for it. How am I storing the salt itself?
That is a great question. The thing I will point to would be the bcrypt README itself, and they have a really nice visualization right at the end to show how the hashed password is stored. So essentially what they're doing is the hash that they generate itself contains information about the salt. So the first part of the algorithm is bcrypt, 2b. Then we didn't talk about this, but there's something called the cost factor. Then they have the salt in here, and then they have the hash value in here. So the salt would be stored as part of the password in the database.
So when I'm trying to re-verify the entered password, how do I extract the salt out of that?
No, that's a great question. So bcrypt's library will take care of that for you.
I see.
There's, I think, must be somewhere like a compare function that just knows that this is bcrypt, so it knows that it's going to break down the salt. And I don't know if this will help, but the salt is always going to be 16 byte. So they know the length of the salt. That's why they can break it down.
I can't use my own comparator. I will have to use the algorithms.
Yes, yeah. Unless you write it your own, because you're using bcrypt to hash them. So you would probably use bcrypt to verify.
Thank you. Finally, just about the JWT tokens as well. One point mentioned that the client securely stores them. How would a client securely store them, you think?
That's a great question. So this, I purposely left it vaguely because it could be a few different slides and I don't want to bore you guys with all the details. But securely is debatable, but usually what you'll see people recommend is using something called a HTTP-only cookie. It's a cookie that prevents against specific types of attacks like cross-site scripting, and there's a few different attacks it protects against, but it would be a cookie that is only accessible using HTTP requests. So the JavaScript, which by mistake could have seeped into your database, is not being able to access that JWT and make requests on behalf of the user. But yeah, it's like I said, could be a whole talk of its own.
Thank you.
Anyone else in the room?
I have two questions.
Yeah, go on.
Okay, what do you advise? Okay. Okay, so what do you advise a front-end developer? What kind of relationship do you advise when sending a password over the internet? Do you suggest or advise sending the plain text or encoding it or encrypting it before going to the API?
Okay, I see what you're saying. You're saying, if I'm understanding it correctly, is when the user is entering their username and password on the login form and it's getting sent to the server.
From the client side to the server side.
Right. That's a good question. So like we kind of saw, if you are using any sort of encoding, which let me get back to, it's right here, it's easily reversible, right? So if it's against an attacker that knows it's encoded, they're going to be able to decode it either way. So encoding won't help you. If you hash them on the client side, then the server can't know what the original password was. So you run into kind of this problem where there will be a moment where the client will need to send the password as plain text to the server, but only once. And as far as it doesn't end up in the logs of the server, like server is not logging what the user's password is, which could be seen by other employees, for example, it should usually be fine. If it helps, it's all done over HTTPS, which is a secure tunnel that's created between the client and the server using encryption. So it's only the client and the server that can understand what's flowing through, not anyone else who's listening in on the network. But I guess the takeaway would be don't send your passwords over HTTP, because that's someone could be listening in on the network and they could see what the password is before it reaches the server.
Okay. Okay. So the other one is in using JWT token, you discover that sometimes you are working with some developers. They leave the environment. They probably know how the JWT was generated.
Mm-hmm.
What it means is that they can actually decrypt it, even though they are no longer working with the organization. So how do you handle that situation?
That's a very good question. So the thing about JWT is we try to keep them short-lived. So there's another thing, let me find it, in the JWTs that I kind of sneakily mentioned here called expiration time. We try to keep JWT short-lived to 4 minutes or 5 minutes or sometimes even less. So even if someone gets access to a JWT of a user, they would only be able to use it for a few minutes before the client needs to request a new JWT. So we try to keep them short-lived to prevent against people just borrowing them and using them on behalf of the user. Is that kind of what you asked, or was it a different question?
Yeah, I'm the developer. I'm the backend developer. Yeah, I know the algorithm I used for the development of that JWT.
Mm-hmm.
So if I leave the company today, I'll still be able to log into that application because I can decrypt.
Okay, I see. Yeah, so the JWTs are created by the server using something called a private key that only the server knows. If, in your case, the backend developer knows the private key and they take it with them, usually the best practice is to rotate the private key automatically. So AWS or other cloud providers have services to rotate them regularly to prevent against this. Or the access to the private key shouldn't be something that everyone has access to because they don't need to. So there's a principle of least privilege that we talk about in security, which is if someone doesn't need to know what the private key is, don't let them see it to prevent against those scenarios. So yeah, rotation of private keys and keeping the access to a private key only to a specific set of people would probably help prevent against it. But there's no guaranteed prevention in a lot of these things. Yeah.
Yep, we got another 2 questions here.
Yeah, I'm just curious, you're talking a lot about problems and how they're solved. So if an attacker X, if an attacker Y, here's how we stop that.
Mm-hmm.
If you were the attacker, how would you thwart all these systems? If you had to get in, if you had to defeat this authentication process, all these things sound great and they sound really helpful, but let's say your task was actually to break them. Are there vulnerabilities you're aware of? Are there things that you would exploit?
That's a great question.
I know you're willing to talk about that.
No, that's fine. So I think what I found is social engineering attacks are the one that is the easiest and probably the most powerful. So you'll see these scam calls coming in asking for your OTP to bypass multi-factor authentication. It's much easier than trying to break into your iPhone using your bypassing biometrics and getting access to your SMS, right? Just call them, pretend you're someone you're not, let them give access. Or people using weak passwords. So if you're using passwords that are about your pet or where you were born, usually you try to target those users because let's say they signed up to a website which wasn't using some of the practices mentioned here, their database got leaked, and now suddenly on the dark web you have access to all sorts of database dumps of people and their passwords, and now you can suddenly log into their bank accounts. But this is kind of me dodging the question, right? If someone was being very careful and they did all of these best practices, and there's so many more, it would be very difficult to break into those systems. Usually there are things like vulnerabilities or zero-day vulnerabilities that pop up in some of the libraries we use. So for example, bcrypt in itself had a vulnerability a few years ago. So as soon as that is known, you try to basically attack that and hope that the developers don't upgrade the dependency versions before you get around to it. So, like most of us, if you're not bothered by upgrading dependency versions, maybe your security team will be on your ass basically telling you to upgrade them because this is what attackers take advantage of.
Who are you trying to attack?
This time I'm not willing to comment.
Did you have a question?
Yes. Different question, I suppose. So we talked about...
Just after this one. Sorry, there was someone in the back, but
Oh, sorry.
we can ask.
Sorry.
Yeah.
The single sign-on with Google we talked about, and we
Yeah.
talked about email and password sign-in. But I'm seeing there's a trend of like the magic links in the email, sign in with email. Now, my question is either, I was thinking, could it be a JWT that is being used for that? And I guess that's my question. And if it's not, you don't need to go into it just now. I can Google it later, but I'm just kind of curious.
No, that's a good question. So usually when we do magic links, they are more about authentication rather than authorization. So I think the flow that you're talking about is you go to a website, you put in your email address, they don't even ask you your password, they don't even ask you to sign in with Google. They email you a button which has a link. When you click on it, suddenly you're logged in, right? So that's more of a authentication question. I think they would probably be using JWT from that moment on to make sure you're accessing the resources using JWT. But in that case, I think it's a good thing because now the developer of that website doesn't need to maintain passwords at all. Like it's kind of solving a problem by not even storing passwords, right? Like if you don't have to store passwords, you don't have to worry about hashing, salting, upgrading dependencies. You just email them the link, they click on it, and now they're authenticated. So yeah, I don't know if that answers your question, but yeah.
Thanks.
Yeah, no worries.
Is there
I think we have a
another
question at the
Yeah.
back.
How important is it to keep your hash function and your authentication strategy secret?
Wow, that is a great question. So there is this term in security called, I'm going to pronounce it wrong, security by obscurity or something, obfuscation. But yeah, it's essentially this way of doing security where you basically don't tell the other person how you're doing it. There are cons to it. For example, if you think about Signal, Signal is a popular messaging app as an alternative to WhatsApp. They both have end-to-end encryption. End-to-end encryption, you can kind of refer to some of the concepts we talked about here, uses a mix of symmetric and asymmetric encryption. But Signal takes an approach where all of their code is public. On GitHub, you could go right now, see Signal's code. They're saying, if we have vulnerabilities, we want the good actors to tell us by looking at the code, rather than hiding them and hoping no one finds out about the bad code we have written. So you can hide the way you're doing hashing, you can hide the way you're doing things, but open source world thinks that telling everyone how you're doing it and letting them tell you what you're doing wrong is the better way, rather than hiding it. So there's both ways of doing it. WhatsApp, for example, is not open source. They hide the way they're doing end-to-end encryption. People think they're not doing end-to-end encryption. Maybe they're monitoring all your stuff. But yeah, I think there's both sides to it, and it differs from product to product, company to company, because not everyone can make their code base public for different reasons. Yeah. But usually, I think if you were to use any sort of hashing, it would be a mixture of what we talked about here. So it's maybe not as secret because people would figure it out.
Is there anyone else, or is that everything? Okay, awesome. Do you know what I love about that talk, Mihir? And what I love about you?
Go for
You're
it.
the least insecure guy I've ever met.
That's a nice one.
Do we think you did a good job? Amazing job. Really well done.
Thank you.
No, thank you very much. You're free. Relax. Enjoy yourself now.
Thanks, guys.
Just before I hand over to Jamie, just a couple of things. First of all, thank you very much to Barclays Eagle Labs, who have been a great host for the entire year. Secondly, while I've got the platform, I'm going to do a little plugging as well. I've recently started a new community in Glasgow as well. It's called Glasgow Remote Workers. I made this community because I aspire to be a digital nomad and I wanted to meet more remote workers in Glasgow. So our first event is going to be on the 21st of November. It's going to be in Platform, which is just across the bridge there. It's just going to be a small networking drinks. You can find us on Meetup as well. It's Glasgow Remote Workers. So if you're interested, come talk to me or come along on the 21st. So now, without further ado, I will hand over to the other Jamie.
Thank you.
All yours.
People are now going to get us confused, and there's another Jamie that used to run EdinburghJS as well, so it's kind of there's maybe a requirement for that. Cool. I just wanted to take a couple of minutes since it was a year ago that we relaunched GlasgowJS after the pandemic. So I don't know if people know much about me, but I'm Jamie. I live in Edinburgh. I've been running EdinburghJS for a few years, and sort of took over GlasgowJS as well to sort of save the Meetup group. Because Meetup decided to delete your group if you don't pay for it for a while. So yeah, save both the groups. And I just wanted to kind of look back at some of the stuff that we've done with a view to kind of triggering a little discussion afterwards on what you want to see next year. So we relaunched in November. We had a little social evening. You're going to see a few familiar faces here, which is nice. So we had a social. We've heard, I'm just going to loop through all the speakers because I'm just going to want to call out the range of people we've had. So we heard from Ryan, who talked about building full stack apps. So we've learned about kind of what goes into, you know, in his opinion, what goes into building a full stack app, all the things that you need to think about. We heard from James, a talk about building something for the ferries to Shetland and then selling it. He got, I think, a few £100s out of it, you know, well paid as a developer for that effort. We heard from Doro, who did a talk about accessibility, a very important topic I think we could all bear in mind. And Muzaffar talked about building a 13-month calendar, kind of illustrating some of the kind of ways that as developers we kind of find out about the world and like kind of all the little intricacies and stuff that you get when modeling a real-world system. So that was super interesting. We heard from Frances, who did a 15-minute kind of live code of her talk on React Native with Expo, absolutely excellent. And Patty, who talked about TensorFlow.js and AI. We heard from Kelsey on green software, and Christopher on automating API governance. Excellent talks. And this was the point that we started publishing them on the website so that people can look back in 4K. We can see in high def for your talk as well there, Kelsey. We held a community night, which was a bit of an experiment. Not something that we tried before, but basically you can show up and have your 5 minutes talking about basically whatever the hell you want, as long as it's somewhat related to JavaScript, the web, or development. So that was a really good experiment, and nice to give people, I think, the opportunity to speak where maybe they wouldn't want to do a full 20-minute talk. June, we heard from Albert on simplicity and systems. Albert works for Spotify, so it was good that he came and chatted to us about the way that he thinks about development, kind of at the meta level. September, I did a talk on personal websites, which is something that I bang on about all the time, and I will continue to bang on about next year. And we heard from Alistair on volunteering in tech. October, we heard from Kat on building linters. Kat is actually someone who had spoken at EdinburghJS in the previous year and then came back to speak at Glasgow. So yeah, I like welcoming people back. So if you've done a talk before, please feel free to come back. And Jaime came up from England to come and speak to us about Tres.js and kind of 3D stuff. And of course, today, little stage photo, yep, made it into the presentation about authentication and authorization. Lovely. Yeah, you recognize that guy. Cool. Just a little word of thanks to the volunteers for this year. Really appreciate the help. Alan, who does all the live streaming and the video recording, very much appreciated. If you're ever running another event and you want to pay someone for that, hit Alan up because he's very good at it. Victoria, Stephen, Ronak, Tanu, Marge, Jamie, and Jack and Peter here at Barclays. Everybody that's helped out just with the events, either guest hosting or putting stuff away at the end or whatever. Sponsors, thank you to Barclays Eagle Lab. They've been a great help. They've paid for the pizza for the entire year and they give us this room for free. Really, we literally couldn't run it without their support. Scotland Is gave us some money to help us get set up with some more of the live streaming and video stuff, which is why you can now see the talks on the Scottish Technology website. And Glasgow City Council have given us some money from their Meetup fund. So next year, we're going to do 3 blocks of 3, I think. So 3 months and a break, then 3 months and a break. What I want to know from you after we finish up here is topics. Let's go out there. Let's talk about what it is that you want to know about next year. Is it frameworks? Is it deep dive into technology issues? Is it knowing about things like authorization, authentication, the kind of meta level that might apply to lots of different things? Is it maybe dealing with some web stuff like CSS or whatever? If you want to speak or if you know someone who wants to speak, please do get in touch. I love it when people just come up like, hey, I can do a talk, because it makes my life easier. And I would encourage people. I mean, that was all right doing that, wasn't it? It wasn't too daunting. It was good. I think we've had people who've been worried about doing talks before, but after they've done it, they've been like, oh, that was easier and friendlier than I thought it would be. Even people who stress a lot beforehand, in retrospect, are glad that they've done it. Formats for evenings, workshops, things like that, or where we bring our laptops and code. What panel discussions? Let me know what the kind of things you want to see. Maybe some ideas for that, or maybe events with recruiters where we can talk about tech careers. Give me suggestions. Online events, maybe in between meetups, we can do like co-working, get-togethers, hacking on a certain topic online. Sponsors. In Edinburgh, some people in the audience have gone back to their company and been like, hey, do you know who you should give a few £100s to? And that helps us out. Like, it costs about £300 to put on, like, for food and drink and, like the Meetup group subscription or whatever, per month. I mean, it depends on numbers, obviously, turning up and eating pizza, but that's roughly it. So if you can help for a month, that's great. If you can book a 3-month block, even better. Ask your company. They can have their logo on the screen. They can have their logo in Meetup, backlinks for SEO. I don't know, whatever you want. I'm willing to sell you. Community Scottish Technology Club. This is something that I kind of started up to for both the Edinburgh and Glasgow communities. So I'm just going to show you what it is that I do. So every week I scrape Meetup and Eventbrite and a couple of websites, and I provide a list of things that are on this week. So you can see here, November Meetup, Demystifying Auth. All the links go straight through to like the Meetup page or whatever. So there's no like crap. It's just links to the stuff and the city that it's in. I do a kind of 3-week view for what's on, which kind of goes down so you can like see a little bit further in advance. We have the video library, which has these lovely. I quite like these little animated things. It looks quite nice. So you can catch up on the talks there. And Victoria, who's at the back there, runs the mentoring scheme. So if you want to mentor or be mentored, get in touch with Victoria, and she will put you in touch with anybody who's listed here on the website. Every week, every Monday, I sit down first thing on Monday morning, and I write this little bulletin and send out via email that has kind of what's been happening, a little photo of an event in the previous week, content. So if people have been blogging or streaming or posting videos or whatever, I try and list it if it's somewhat relevant to tech. There's a few people who basically, Luke Shea from Edinburgh gets in every week. He does a video every week, so consistent. He has grown his channel on YouTube from, I think, 100 people when he joined to just under 2,000 now. So, that's because he was so consistent. If you've got your own website and you're posting like a roundup of tools that you've enjoyed in 2024 or whatever, send me the link. I'm happy to feature it. It's good to be in touch with other people in the community. So I send that out via email every week, and I tag people. I tag everybody in the community Discord just to let them know what's going on. The other thing that I'm setting up is Blue Sky. Tech Twitter seems to have migrated. It's nice because I can now put the Blue Sky kind of tweets, skeets, posts, whatever you call it. They're now on the website. So I'm going to be reposting material from other meetups, just kind of to get that kind of cross meetup thing going. So for instance, Glasgow PHP is back this month. So go and check that out if you're a PHP developer. I'm sure some of you are. So basically that's what I'm running. There's QR codes on the table outside if you want to join the events bulletin email or to get the Blue Sky starter pack of speakers that are there. So I'm just really keen to hear from you. I think we've had a really great year. I appreciate everybody that turns up to these events, and I appreciate everybody that helps out. So come at me with my ideas for 2025, and if you want to get involved, please just come and talk to me about it. That is all. Thank you.
So what's next? Are we just going back up there?
Yeah, just back out there and have another beer. And there's the pub in town. What's it called? It's the one next to St Enoch.
Hootenannies.
Yeah, Hootenannies. Yeah, that's the one. So.
Awesome. Well, we hope you've enjoyed yourselves tonight, guys. Let's give one more round of applause for Mihir and for Jamie as well. Fantastic, both of them. And yeah, we hope to see you all back next year at the next GlasgowJS Meetup in January. See you then.